Hello, good morning, Year 13 Mac, you lucky students. Here we go again. Now, I'm going to show you how to integrate rational functions that look like this here. Okay? Rational meaning like a fraction, and we have a numerator and a denominator. This thing here that we are trying to integrate is called the integrand. You might read that in some book and not know what it means, but it really means that thing in there, the piece of algebra which is to be integrated. Okay? Now, the basic idea with this thing is to simplify the integrand first before you integrate. And that really means to split up this numerator all with this same denominator, and then cancel what you can and then integrate. Okay, so let's see with an example. So in this first example here, I'm being asked to integrate this thing here, this integrand, 3x plus 7 all over 2x. Well, if I split it up, I can say that I've got 3x over 2x plus 7 over 2x, same denominator. And now I can integrate each part separately. But before I can do that, just simplify it as much as you can. That x will cancel with that x. So you're really integrating 3 over 2 dx. And now you're integrating 7 over 2x dx. Well, you take these constants, 3 over 2, outside the integral sign like that. And so you're really integrating 1 dx. And this 7 over 2, you can take outside the integral sign. And what are you really integrating? You're really integrating 1 over x dx. Well, we've just seen that if I integrate 1 over x, I'm going to get the natural log of the absolute value of x like that. So my final answer, when I integrate 1 dx, I get x. So this is going to be 3 over 2 times x, or 3x over 2, plus 7 over 2 times the natural log of the absolute value of x plus c. Pretty straightforward. Here's another example. My integrand is this thing here, 3x squared minus 4 all over 5x. Again, split it up. I've got 3x squared over 5x minus 4 over 5x. This x here in the denominator can cancel with one of the x's there to leave me with just 3x on the top. There it is. And here I've got, there's no simplification I can do there. I've just got that x on the bottom. However, I can take the 3/5 outside the integral sign, there it is, and integrate just x. Well, if I integrate just x, I get x squared. I must divide by the new power, which is 2. So when I do that, I get 3x squared over 10. There it is. Now what have I got here? Well, I'm being asked to integrate this. Well, if I take the 4/5 outside the integral sign, there it is there, I'm left with really 1 over x to integrate, and that is the natural log of x plus c. Okay, so there's your final answer for this example here. Now I'm just going to zoom out to the next page, which is this one. Yep, and then I will zoom in and show you how to integrate something that looks a bit tricky. Okay, here we go. So example 3, you've got the same problem. Everything is over the same denominator. This time we've got an x squared on the bottom. So we split it up. So we've got 5x over x squared, and we've got 9 over x squared. Well, we simplify, that x can cross off with one of those, so we're left with 5 over x, as you can see here, and we're being asked to integrate 9 over x squared. Well, this 5 that's multiplying the numerator here, we can take outside the integral sign there. What are we left with? We're left with our old friend, 1 over x. which is the natural log of the absolute value of x there. Here we have to be a wee bit careful because we can bring this x squared up to the top. Well, let's get rid of the 9 first. Put the 9 outside the integral sign. Take the x squared up to the top, and it becomes minus x to the power of minus 2. Now, we're going to integrate x to the power of minus 2. And what we do is we increase the power by 1. There it is. But we must divide by the new power, which is this minus 2 plus 1. Well, minus 2 plus 1, of course, is minus 1. And when I make this power here and I calculate this new power here, it comes to x to the power of minus 1, which I can take to the bottom and write x to the power of positive 1 there. And this minus 1 is going to change this plus sign to minus. So your final answer is going to be 5 times the natural log of the absolute value of x minus 9 over x plus c. Okay, now let's look at one that's to do with a little bit of trigonometry here. Supposing you're asked to integrate something like that. Well, again, you've got two terms in the numerator over a single denominator. So split it up. And that's what I've done here. I've written the integral of 2 sine theta over cos theta plus 1 over cos theta, all d theta. Now, of course, sine over cos is really tan. So we're really being asked to integrate 2 tan theta plus, now 1 over cos is sec theta. So we can do now the integration separately. We can integrate 2 tan theta d theta and integrate sec theta. Well, when we integrate tan, you should now know from your your table of integrals of trig functions that if you integrate tan, you get sec squared theta, and if you integrate sec, you have sec theta tan theta. So the final answer to this one is 2 sec squared theta plus sec theta tan theta plus the constant of integration. Okay, that's it, guys. So yeah, there's another lesson coming up.